Hello everyone, my name is Chloe Liu Zitong and these are the group members of our group. Chong Li Xuan, Luan Kai Xuan, D01 and Shashai Shabin. In this experiment, a number of restaurants feature a device that allows debit card users to swipe their cards at the table. The device allows users to specify either a percentage or a dollar amount to leave as a tip. A random sample of debit card users was drawn. Some paid using the usual method and some used the new device. The percentage left as a tip was recorded at this. The following question were given for analysis. A. Find the mean and median for each group of the dataset. B. Compute the standard deviation and coefficient of variation for each group of the dataset. C. Estimate the 95% confidence interval of mean values for each group of the dataset and interpret the confidence interval. D. At the 5% significance level, show the procedure of hypothesis testing based on the following hypothesis statement. Can we conclude that users of the device leave larger tip than those who paid the usual way? For the usual group, the mean was 12.62 and the median was 12.6. The standard deviation was 1.718 and the coefficient of deviation was 13.6%. The 95% confidence interval ranged from 11.39 to 13.85. For the device group, the mean was 14.2 and the median was 13.6. The standard deviation was 1.614 and the coefficient of variation was 11.37%. The 95% confidence interval ranged from 13.12 to 15.28. This indicates that the usual group has slightly higher variability than the device group. The graph shows a comparison between the usual and device group in terms of mean, median, standard deviation, coefficient of variation, and confidence interval. Based on the analysis, we can conclude that users of the device tend to leave larger tips than those who paid the usual way.
Hi Meta and hi everyone, I'm Li Xuan and next we move on to hypothesis test to find out whether the new device really increase topic behavior. We start with our hypothesis. The HO assumes that this percentage from the device are less than or equal to twice from the user method, and the H1 suggests that using the device led to higher test. We use a two-sample t-test because we are compared the mean for two interpreted group at a 5% significance level. The critical t-value is 1.729 and our concrete the t-statistic is 2.173, which is good, which is greater than the critical value. The mean which we reject the HO, then we conclude that using the device significant increase behavior.
name is Long Kai Shen. Today I will be presenting question 2A, B, and C, the results of a simple linear regression analysis examining the relationship between body weight and serum cholesterol level. First of all is question 2A and B. As the slide shows, the dependent variable is the level of serum cholesterol in mg, and the independent variable is body weight in pounds. The multiple R is 0.278 and the R-square value is 0.077, suggesting that body weight explains about 7.7% of the variation in serum cholesterol levels. While this is a modest relationship, it is statistically significant with a p-value of 0.049. Presenting the question 2C. From the regression output, we obtain the following estimated regression equation: y hat equal to 184.08 plus 0.209x. This means that when body weight is 0, the expected cholesterol level is 184.08 mg, which is our intercept. The slope of 0.209 indicates that for every additional pound in body weight, the serum cholesterol level increases by approximately 0.209 mg. In conclusion, although body weight is a statistically significant predictor of serum cholesterol, it only explains a small portion of the variation, suggesting that other factors also play a major role. That's all from me. Now I pass it to my friend D01. Thank you.
Hi everyone, my name is D01. Today I will be presenting question 2D and E. From this slide, we can see the coefficient of correlation R is 0.2787. This means there is a weak positive correlation between body weight in pound and serum cholesterol level in milligrams. In simple terms, as body weight increases, serum cholesterol tends to increase slightly, but the relationship is not strong. Next, the coefficient of determination R-square is 0.0777 or 7.77%. This tells us that only 7.77% of the variation in serum cholesterol levels can be explained by the variation in body weight. The remaining variation may be influenced by other factors. So although there is a slight link, body weight alone is not a strong predictor of cholesterol level. That's all for me now. Next, I will pass to my friend.
Good day, everyone. Our analysis focused on the association between body and serum cholesterol levels. We hypothesized that there is a significant association between these two variables. As you see from the ANOVA table, our F statistics is 8.25 with a p-value of 0.004989. Since this p-value is less than our significance level of 0.05, we reject the null hypothesis. This indicates a statistically significant association between body weight and serum cholesterol levels. The scatter plot further illustrates this relationship. As the body weight increases, serum cholesterol levels also increase, showing a positive linear relationship. The positive slope confirms the positive association between the two variables.